So for today's notes, we're going to be working on polynomials, synthetic division. And so a little bit of a note of synthetic division, that it works when the divisor is a binomial. So we have our coefficient here is going to be 1, and then we have a constant of some form over here. So our first step is going to be to actually take the negative of that constant. And the reason why this is because when you divide, you always do like your multiply and then you subtract and then bring down. So by doing the negative of my a, that incorporates the concept of that subtraction, of that you're going to end up taking the opposite signs of everything when you actually end up doing your division. So you're going to take the opposite of your a and then write it with that new value and this little like reverse or half of the box here. So if we have the example, given our example of x minus 2, we're actually then going to write down plus 2 and then set up our, what is kind of like an inverted division box. Basically what we got going on here, separates it out. So step 2, we're going to take the coefficients of our polynomial, making sure that if we need to, we add zeros where we need to. So if we have, in this situation, we have x to the third, x to the second, we don't have an x to the 1, and so that actually is going to be rewritten with 0x to the 1. And then we're going to take all of those coefficients and write them right next to this 2 that we had out here. So here we have our setup for our synthetic division, fundamental. And so from our next step is going to be to actually draw in our base information. So we're going to be adding, we have our line for addition, and then we have a little box down here that goes below our very last term and our very last coefficient that we had here. And that is going to be for remainders. And we'll get more into that later. So we have our plus 2, we have our coefficients, we then draw and set up our actual addition problem that we have here, and then we can start in the math. And we're going to first do that by dropping down, and the reason why is because the first number always ends up, when you do division, being basically the same thing. So drop down the first number. Step 5 is you're going to multiply that number by our number out here, our negative a. We're going to add it to our next number, and then we're going to repeat that process again of the answer multiplied by here and then added to our next number, multiplied by our outside number, added to our next number. And so let's go ahead and take a look at what this looks like. So we have our problem. And so what I did is I dropped down my 3. I did 2 times 3, which gave me 6. And then I added 4 plus 6 gave me 10. I times 10, that's a little blue dot here, by 2, because that's my number out here. And I get 20. 0, remember we're adding all these ones together. So 0 plus 20 is 20. Put my blue dot for multiplication of whatever number this is. Put my answer here, and then I add. Now, if this comes out to be a perfect 0 here, then that means that you have a nice even factor, and it goes in without any remainders. If the number in the box, then there is remainder, and the divisor what we had out here, is not a true factor of the dividend of what you were dividing into. So the step 8 means now that I have all my digits here, how do I write it into an actual algebraic expression? So write it as a polynomial using the second largest exponent to start. So originally the problem was an x to the third, so we're going to use the next largest, which would be x to the second. And we're going to write it in the form of our x minus a, which is basically the same as to whatever you were originally dividing by up above. Your quotient, which is going to be the transition of this, and with our x's and our exponents, plus, and we have PA, which is going to be our remainder if you have one. So let's go ahead and scoot this up a little bit. What you have is this here. This was my original divider. And then we had, there's my coefficient for my x squared. There's the coefficient for my x. There is my last term. So put all those together, because if you don't, then you can basically add these up, and that would be wrong. But you want to put those together so they stay as a polynomial, and then we have a plus 50, which is your remainder. Obviously, if there was a 0 here, then your answer would just be that, and you wouldn't have a plus anything at the end. And that is how you do synthetic division. All right, I hope this helped.